Hello, algebra students. Welcome to Factoring Special Cases, Chapter 8, Section 7. If you have not, please fill in the information right here, name and date on that line, and get that down. And you will probably notice I have some blue writing here. I bet you can't read it on your screen. I'm going to make it so that you can here in just a second. I have these three notes, these three steps that I want you to write in this area of your paper up here. Okay, and what I'm going to do here in a second is I'm going to move this. So you write it in this area here. I'm going to move this down so you can read it, make it a little bit larger. Would you write these three things up here? And we're going to refer to this as we go through this lesson. That as we talk about factoring here, these more complicated polynomials, this is three steps to begin with. There's one step that's not in here that we'll add later, probably next week actually. And these are the steps when you factor trinomials that you need to follow. The first thing that you always do is factor out a greatest common factor if possible. Now you need to follow this order as well. You need to do that first. Factor out that greatest common factor if it's possible. All right, once you do that, or if you don't do that, the next thing you should consider is if this particular trinomial or binomial actually that we see today, to see if it's actually a special case, and that's today's lesson. The two possible special cases that they could be would be a perfect square trinomial or a difference of two squares. So you want to look for that right after you factor out a greatest common factor. If at that point you still haven't factored it and it's either a trinomial or a binomial, then you'll have to use one of the methods of factoring that we've already learned in class. And that could be the box method or just the regular method that was in your book from earlier this week and last week too. All right, so if you'd get that down, hit pause if you need to. I'm going to go ahead and shrink it and put it up here because I'm going to need some writing space here as we get into the notes. And this will actually be on the pages as I go through the lesson here upcoming. All right, so I'm on page 523 in your book. We're talking about factoring perfect square trinomials. Now, this goes back to that lesson we had a few weeks ago where I told you it was a mental math lesson, and if you memorize these patterns, it would make your life easier in the future when we factor. Well, this is that lesson. And the patterns I tried to get you to memorize started like this. If we had this trinomial that said a squared plus 2ab plus b squared, we learned earlier this month that that actually factors to a plus b times a plus b, like this. And then since those are the same binomials, we actually could write it like this, a plus b, the quantity squared, because that's what it is, the base a plus b multiplied by itself. Now, quick review, why? Why did this work? So let's go back and remember that when we multiplied a plus b times a plus b, if we FOILed that out, if we multiplied all these terms, a times a is a squared, plus a times b is ab, plus b times a, it's the same as ab, and b times b is b squared. So right here you see there's your 2ab right there, which was that term. This plus sign was here, and we had a squared there, and we had b squared on the end. So what that told us was that if we have a trinomial where that is a perfect square, and this is a perfect square, and this middle term is 2, it's always that number 2, times a, which is the square root of this term, times b, which is the square root of this term, that would always multiply out to this pattern. Now I think when we did it, I gave you this was the question, and then I was trying to get you to figure out what that is. Well, today it goes backwards. And if you have these memorized, it can actually make our life a lot easier. Now, it also worked for this trinomial. The only difference was that factored to a minus b times a minus b. And the reason was, since that multiplies to the positive, you have the same signs. And since that's a negative, it has to add to a negative. So that actually factored all the way down to a minus b, the quantity squared, like that. So that's really review if we think about it. That's that memory lesson from earlier this year. And then the other one That is explained in your book on page 525. If you're factoring a difference of two squares, that always worked out to be this type of pattern, where you have a plus b times a minus b. All right, why? Again, let's look at it. Again, back then I gave you this as the question, and then that was the answer. Today we turn it around as we factor. If we factor a plus b times a minus b, a times a is a squared, b times a is ab, a minus b is negative ab, b times negative b is minus b squared. Well, this is a zero pair right there. AB plus negative AB is 0, and here you have a squared minus b squared. Plus negative is minus right there. Okay, so there you can see it. So now, if I am given this, if I am given a squared minus b squared, I can factor it using, if I know that that's a perfect square, and b squared, if that's a perfect square, I can take the square roots, write them out as two binomials, and have the problem factored right there. And that's a pretty valuable lesson for us. Well, keep that in front of you. Obviously you can. I'm going to go to a clean page. Now I'm going to keep my steps to factoring here and refer to them as we look at our first example. Now everything today is factor, okay? So I didn't write the directions out. So everything we're going to do today in this video is factor. So the first example, let's look at 4x squared plus 20x plus 5. Now I will tell you, you can set this up with a box and do all that, and that would actually be a little more work than if you learned these patterns. Now that's not right, that should be 25. Sorry about that. 4x squared plus 20x plus 5. 25. Okay, I can't talk today. But I'm challenging you to try to start to notice and look for these patterns. Okay, so number one, I'm going to look to see if I have a common factor. 4x squared, 20x, well that could be a factor of 4, but 4 doesn't go to 25, so I don't see one. So there's no greatest common factor. Okay, so we'll skip that. Now you don't have to write this part here down. What you do need to write is whatever I write with my ink over here with the problem, please. All right, number 2 says look for special cases today. Well, it's probably going to be one since this is a lesson. So we're going to look for a perfect trinomial square or a difference of squares. So if I look up at my notes here, well, a difference of squares is going to be minus with two perfect squares. So it's not that, but it might be one of these. So I'm going to consider this pattern. I know it's not a difference of two squares, but I'm going to look to see if it's a perfect trinomial square. Well, if it is, that means that this is a perfect square, and this is a perfect square. Well, let's look to see if it is. All right, well, let's see. 4x squared over here. So over here in your notes, you'll want to write this. I want to know, is square root of 4x squared, is that a perfect square? Can I multiply something times itself and get 4x squared? Well, 2 times 2 is 4. X times x is x. So 2x. So 2x is really my a term here. Because remember the pattern is ax. This is what I'm looking for. Ax squared plus 2ab plus b squared. I'm looking to see if this polynomial fits this pattern. Well, 2x would be a. Then I want to know, is that b right there? Is that 25? Is that a perfect square? Well, that's pretty clear that that is, because 5 times 5 is 25. So that's b. All right, so far so good. So what I want to know is if I take a, which is 2x, times 5 times 2, will I get this middle term, 20x? 2 times 5 is 10. 10 times 2 is 20. It would be 20x. So this does match. So therefore I know that this is a perfect trinomial square. So since that's the case, I can factor this in this pattern. A squared plus 2ab is plus b squared equals a plus b, the quantity squared. All right. Think of it like this. Okay, 4x squared is basically the same thing as 2x quantity squared plus this is 2 times 2x times 5 plus this is basically 5 squared. So there you can see the pattern. There's a squared plus 2ab plus b squared. There's my pattern. So this factors out to 2x, because a is 2x plus 5, the quantity squared. And that would be my answer. Now you could FOIL this out, 2x plus 5 times 2x plus 5, and you would work it back to 4x squared plus 20x. So there's our first example. We have several more to do. We'll pick up the pace in the next video here, as I had to get through all the instructions, and we will go from there in a minute.